A map is a simplified view of the Earth's surface that shows where places and things are located and helps us communicate all that information efficiently. Once you have acquired maps for your project, the next step is analyzing them. Reading maps may seem simple, but there are several elements of maps that can be helpful when analyzed correctly. These include the title, which tells you exactly what you're looking at on that map, the legend, which explains the features drawn on the map, the scale, and any features marked on the map as part of the map's theme, such as contour lines or land use. In this video, we are going to examine two map features that are especially important for you to consider when completing your project. These are the scale and contour lines. The scale describes how the distance on the map relates to the distance on the ground. There are two common ways that scale is represented on maps. One is as a representative fraction, for example, 1 to 24,000. This means that 1 unit of distance on the map is the same as 24,000 of the same units on the ground. So 1 centimeter on the map equals 24,000 centimeters on the ground, and 1 inch on the map equals 24,000 inches on the ground. The other common way that scale is represented on maps is as a graphic bar or bar scale. Simply use the graphic scale to measure distances on the map in terms of ground distances. Maps drawn at a small scale, such as 1 to 250,000, are less detailed and show more land coverage, such as in this map. Maps drawn at a large scale, such as 1 to 24,000, are much more detailed and therefore cover less land area, as you can see in this map. The other important feature to pay attention to is the use of contour lines to represent topography. For this project, it will be important for you to locate at least one map of your area that has contour lines, so you can analyze the land surface around your proposed sites. Each contour line on a topographic map represents a certain elevation. Contour lines are evenly spaced apart in terms of the elevation. For example, if a map uses a 40-foot contour interval, there will be contour lines drawn for every 40 feet of elevation change. It is important to look carefully at the map to identify the contour interval being used. Every few lines, there will be an index contour line. The elevation will be marked on these index contour lines so you can figure out which elevation each contour line represents. Where the terrain is steep and the elevation of the land changes rapidly, the contour lines on the map will be closer together. Where the terrain is flatter, the contour lines on the map will be farther apart. Analyzing the scale and contour lines of maps allow you to gather a great deal of information at one time.